So what we're going to look at in the next number of lessons are what are called complex numbers. And complex numbers is another what's called a number system. And we've looked at different types of numbers so far to date. So if we think about something like this, so for example, x minus 5 is equal to 3, and we can solve this for x. So we have to add 5 here and add 5 here, and x then is going to be equal to 8. So these guys cancel out, and 3 plus 5 is 8. So x is equal to 8. So 8 is a number. What type of a number is it? So 8 is actually what's called a natural number. So this number 8 is an element. So this means element of n, and n represents what are called natural numbers. So this number 8 is what's called a natural number. And if we think about, so natural numbers are, for example, 1, 2, 3, 4, 5, all the way up to all the way right up to what we call infinity. So something like that, okay? So these go all the way up to infinity, and these are called natural numbers, and the letter that we use is n. And this just means that the number 8 is an element of the set of natural numbers. So again, just natural numbers. If we take something like this, so where we have x plus 5 is equal to 3, what we need to do is, if we want to get x on its own, so we have to subtract 5 from the left and then subtract 5 from the right, like so. And that will leave us with, so x, so these two will just cancel out. So x is going to be equal to 3 minus 5, which is going to be equal to minus 2. So if we take, so this is another type of number, and this 2, so minus 2, is an element of z, and z, this letter z represents what are called integers. And integers are, so for example, you have positive, so 1, 2, 3, so these are positive integers, and this goes all the way up to infinity, so it just goes on and on forever in this direction. And then also the opposite way, so you have the negative whole numbers, so minus 1, minus 2, and then all the way to infinity as well on this side. So these, like positive and negative whole numbers, these are what are called integers. And again, they're part of the number system, and they're donated by this letter z. So this just means that minus 2 is an element of z, and z represents the set of numbers which we call integers, and these are what integers are. And then also as well we have, so let's say this is like 1, this is 2, and then we have something like this. So if we have, for example, 3x, so 3x plus 5 is equal to 3. So again, what we want to do is we want to get 3 on its own. So we have to, so we minus 5 from this side, and we minus 5 from this side. So these will cancel out. This will leave us with 3x is equal to, so 3 minus 5 is equal to minus 2. And now to get x on its own, we have to divide this side by 3. If we divide this side by 3, we have to divide this side by 3. So these will cancel out, and you'll be left with x is equal to minus 2 over 3. So again, this is another type of a number, and this is what's called, so this x is equal to minus 2 over 3. So minus 2 over 3, so this is actually an element of q. So minus 2 over 3 is an element of q, and this, so q, these are equal to what are called rational numbers. So rational numbers. Like, what are rational numbers? So rational numbers, so they take this form, so they take the form, let's say, so a over b. So you have the numerator and the denominator, and so a and b are elements of z. So all that means is that basically rational numbers are fractions. They're numbers that can be written in fractions. So for example, x can be written as a fraction here. And the numerator, denominator, they are elements of integers. So they can be positive or negative whole numbers. So for example, so these are integers here. And it's just in this form. And we referred, the letter that we use to represent this set of numbers is q, and they are what are called rational numbers. So a way that we can kind of represent this then is, so we have, for example, natural numbers. And then including natural numbers are z, which represent integers. So for example, natural numbers are just the positive numbers from 1 up into infinity. Integers are the positive and negative numbers all up to infinity. So the set integers, it includes natural numbers. And then if we take then one above that, so we have q, which represents these rational numbers, and rational numbers include integers as well. So they include natural numbers, integers, but they're in fraction form. So these are what are called rational numbers, and we represent them with this letter q. So we can see that natural numbers are a subset of integers, and integers are a subset of rational numbers. So that's what we mean by these. So it's just important that we know, like, what natural numbers are, what integers are, what rational numbers are, and that we know the symbols to represent each. So the letter N, capital N, represents natural numbers, capital Z represents integers, and the capital Q represents what are called rational numbers. And this just means like an element of Q. So it just means that this number here, for example, is an element of, it's a rational number. This just means that minus 2 is an element of integers. It just means it's part of the set of integers, and the same with this guy up here. Then we have something that looks kind of like this. So if we were to take, for example, x squared is equal to 2, and we want to solve for x here. So what we need to do is, in order to get rid of this power, we'd have to square this. So you'd have to square this, and then you'd have to square this as well. Now, what will this look like then? So x then is going to be equal, so x is going to be equal to plus or minus the square root of 2. Now, if you like put this into your calculator, just take your calculator out and get the square root of 2, you're going to end up with something like this. This number will just continue on and on and on and on. And what we can say is that this particular type of number here, it's non-repeating and it's non-terminating, so it doesn't end. So it doesn't repeat, but it doesn't end either. And it's a decimal. Now the problem with this is that you can't take this and write it as a ratio or as a fraction. So this kind of a number here, where x is equal, where you get this, like this kind of a number here, because it can't be written like this, it can't be written as a fraction. This number here, this type of a number, is what's called an irrational number. So it's an irrational number. because it can't be written in this form here. So a over b, where a or b is an integer. So you can't write it in this form. So again, this is what's known as an integer, or sorry, as an irrational number. Examples of irrational numbers then as well would be if you were to take, for example, the square root of 2, or the square root of 3, or the square root of 5. So these will all give you, they'll all give you something similar. So all of these guys here, they will give you like numbers similar to this. So they're non-ending, non-repeating numbers as well. So again, these are examples of irrational numbers. Now, not all square roots are irrational numbers. So if you were to take, for example, so the square root of 2, sorry, the square root of 4, that's equal to 2. Okay, so not all square roots are irrational numbers. So if you take something like this, the square root of 2, this is an irrational number. Okay, you can classify it as a natural number. So one of the best irrational numbers that we have is this number that's what we call pi. So for example, pi is equal to 3.1415921592, and then this just keeps repeating on and on and on and on. So pi, for example, is an example of an irrational number. Now, we can't write pi as a fraction, but if we were to roughly write it as a fraction, it would be roughly equal. So this kind of wavy line here means not exactly equal, but kind of equivalent to, it'd be roughly 22 over 7. So it'd be something like that. So again, this is an example of what we call an irrational number. So if we take all of these numbers then, so we have, for example, integers, natural numbers, rational numbers, and irrational numbers. They all come under the class of OR. So OR is like a real number. So real numbers. So all of these sets that we've looked at are what are called real numbers. So if we were to take this guy up here, so real numbers. So everything, all the numbers, all these different sets of numbers that we've looked at will be classified as real numbers. Okay, so they're called real numbers. Real numbers, they get this letter OR. Okay, so OR, we classify them as real numbers. So if we take a question something like this, so what we want to do is we want to show that each of these are rational numbers. So remember, if it's a rational number, so if we take, so Q is equal to rational numbers. So it's the letter that we use. And if they are rational numbers, they can be written in the form A over B, where A and B are elements of Z, which are integers. Okay, so remember, integers are the positive and negative whole numbers. So what we're saying is that if we can write these in this form, A over B, where A and B are integers, then we can classify these as what are called rational numbers. So remember, rational numbers can be written as a fraction, where the numerator and the denominator are integers. So let's have a look at this and see. So if we take question 1, so 5.2. So can we write this as a fraction? Well, if we take, so this 2 part, so this represents the tenths section. So what we can actually do is we can write this, it can be written like this. So 5 plus 2 over 10. Okay, so we can write it like this. Okay, we can simplify this. So if we take 2 over 10, if we divide the top by 2 and the bottom by 2, this is going to be equal to 5 plus 1 over 5. So all we've done here is we've divided the top number by 2 and the bottom number by 2. So this is equal to 5 and a fifth, okay, which is a mixed number. And then if we want to turn this into a top-heavy fraction, what we can do is I can multiply 5 by 5 and then add the 1. So that's going to be equal to 5 5s are 25 and 1 is 26. 26 over 5. So again, what we can see is that we've now changed this into this form. So a over b, we've taken this number and we've turned it into a fraction. And we can see that the top number is an integer. Okay, so it's a positive whole number. And the bottom number is an integer. It's a positive whole number as well. So it's in this form, a over b. So therefore it's classified as a rational number. So this first one, so we've shown that 5.2 can be classified as a rational number because we can change it into a top-heavy fraction like this. If we take the second number then, so the number is 0.3333. Now what we want to look at is, can we turn this into some kind of a fraction? So let's have a look and see what we could do with this. So we can say that x is equal to 0.3333. So we just let this be equal to x. And then what we can do is we can multiply both sides by 10. So what would happen is this would become 10x. So we're just multiplying this by 10. So this will become 10x. And then if we multiply this by 10, we're going to move the decimal one place to the right. So this will become, if we multiply both sides by 10, so this is going to become 3.333, okay? 3.333, like so. So it'll become, this is what it'll become. So what we've essentially done here is we've multiplied both sides by 10. So we've multiplied both sides by 10. Now what we can do is, so we can actually take this whole thing here from this whole thing. So if we subtract, so let's say we write it like this. So just write down here. Let's change this. So imagine we take 10x is equal to 3.333, and then we take x is equal to 0.333. And then what we can do is we can subtract the top from the bottom. So we can just subtract these from each other. So 10x minus x will be equal to 9x is equal to, and then if we take, let's say, 0.333 from this, that's going to be equal to, so it cuts off these guys here, so it's just going to be equal to 3. So it'll be equal to 3 like this. So 9x is equal to 3. And then what we can do is we can solve for x. So if 9x is equal to 3, then if we divide this side by 9 and divide this side by 9, so these will cancel out, and then you're going to be left with x is equal to 3 over 9, like so. So again, what we can see is we've taken this number 0.333 and we've manipulated it and we've turned it into a fraction where x is equal to 3 over 9. And again, we can see that this fraction here is in this form, a over b. So therefore we can say that this decimal here is, we can write it, we can show that it is a rational number in that we can change it into a fraction like so. So we can see that it is what we refer to as a rational number. So then finally then, if we have a look at this one here, so can we write this as a rational number? Can we change this into a fraction in this form here, a over b? So what we can do, we'll have a look at this. So if we take question 3, so it's the square root of 16 over 9. So 16 over 9, we can rewrite this. This is equal to the square root of 16 divided by the square root of 9. So we can change it like this. This is going to be equal to, so the square root of 16 is 4, and the square root of 9 is 3. So again, you can just put these into your calculator and you'll see that this is the case. So what we've done is we've taken this number here and we've manipulated it so that it's now in this form here. So it's a over b, so a over b, and both of these numbers here are parts of the set of numbers which are known as integers, and they're positive whole numbers. And so we can see that this here, that this number, we can manipulate it so that we've shown that this number here is a rational number, because we can write it as a fraction in this form here. Shows us then is that all rational numbers are real numbers. Okay, so we can change these into fractions, so they are all real numbers. So just to recap what we've looked at, so we're starting to look at what are called complex numbers. So we've looked at some of the other common numbers, types of numbers that we have. So for example, we have natural numbers. So this 8 here is the example of a natural number. Capital N is the letter that we use to represent this set of numbers. So this just means that the number 8 is an element of the set natural numbers. So natural numbers are these whole numbers from 1 all the way up to infinity. We looked at this example here, so x is equal to -2. So -2 is an element of z. So this z represents what are called integers, and these are positive and whole numbers. So positive numbers all the way up to infinity, and negative numbers all the way to infinity as well. And they're represented by the letter z. Then we looked at this example here, where x is equal to -2 over 3, and this is an element of q. And these are what are called rational numbers. So rational numbers are basically numbers that can be written as a fraction, where the top number and the bottom number are elements of z. In other words, they're integers, they're positive or negative whole numbers. So again, we can see that natural numbers are a subset of integers, integers are a subset of rational numbers, and then rational numbers are a subset of real numbers. Okay, real numbers are like all of these numbers. And we looked at some examples then. So you also have these numbers. So for example, if we take something like this, x squared is equal to 2. So x then is going to be equal to plus or minus the square root of 2. And if you were to get the square root of 2, so it gives you a number that's like this. So it's a non-repeating, non-ending decimal. And these are what are known as irrational numbers. So not all square roots are irrational numbers. So some of these, like these guys here, some square root of 2, square root of 3, and square root of 5 are what are called irrational numbers. But if you take something like this, the square root of 4, this isn't an irrational number, because it gives you this whole number here. So some very famous examples of what are called irrational numbers are pi, for example. So pi is equal to, roughly, if we wanted to write it as a fraction, it'd be 22 over 7. But these irrational numbers would come within the set of what we call real numbers. So real numbers are basically all of the numbers, all of these particular types of numbers. Like just an introduction to the other types of numbers that we can have. And what we're going to look at then in the next lesson are what are called complex numbers. So we've looked at these other, integers, natural numbers, rational numbers, irrational numbers, and real numbers. And then what we're going to start to look at then are what are called complex numbers. And we look at that in the next lesson. Okay, so thank you for listening.